Incidence, another core part of the epidemiological toolbox. Incidence represents how many new cases of a disease arise over a specified period of time. I say disease because it's sort of more natural to think that way, but we can think about factors in general, so exposure and disease. Incidence counts the number of transitions from absence to presence, so it's a transitional thing. And it could both be one-time events, such as death, but it could also be reoccurring events, such as units of alcohol consumed. And when we think about incidence and we try to measure incidence, we start with a cohort that doesn't have the factor. We usually call that they are at risk, so they don't have it yet, but they're at risk of having a factor. Just like prevalence, we have different ways of measuring and expressing incidence. So we'll go through those now. We have the incidence count. How many transitions from absence to presence over a period of time? So here we see at baseline, we have 4 participants in our study here, and none of them have the disease or factor. As I said, we start with a cohort without the factor. These individuals are at risk. After 5 years, the incidence count is 1, because there's one individual that transitioned to being a case. It's a count, so we actually ignore the ones that were not transitioned. So we could say the 5-year incidence count was 1. After 10 years, there are 3 individuals that have the factor. Now the 10-year incidence count was 3. And as it's a count, we ignore the non-cases, and just like with prevalence, it might not be the best way of communicating incidence because it doesn't really set it into any context. It doesn't give us a reference value to see if this count is big or is it small. You could also express it as of 1,000 individuals who were alive at age 30, 900 were alive at age 35. When you say it like that, you actually know how many individuals you started with. And then in your head, you can think you could calculate some relative measure. But if you just mention the incident count over a 5-year period was 100 in the cohort, it's a little bit more tricky. It ranges from 0 to whatever the maximum number of events are, or it could also be infinity if there is an infinite number of events that could occur. But just like with prevalence, we could also look at incidence proportion. That's the percentage of the at-risk population who transitioned. So same case here, we have a baseline with none of the individuals have the factor. After 5 years, 1 individual has transitioned. That means 1 in 4, the 5-year risk was 1 in 4 equals 25%. And before I said that, I should have said that incidence proportion is such a common measure that we call it risk. So when somebody says risk, we usually mean incidence proportion. Just like prevalence proportion, when we say prevalence, we actually mean prevalence proportion most of the time. When we say risk, we actually mean the incidence proportion most of the time. So the 5-year risk was 1/4, 25%. After 10 years, there were 3 individuals who had the factor, so now the 10-year risk was 3/4, 75%. You need to count the first event, since proportion doesn't make sense outside the range of 0 to 100%. So in this case, once somebody has transitioned, they've transitioned. So with death, that's natural, but maybe not always, because the risk of death, the number of occurrences of death is 1 for everybody, but other things such as certain types of diseases or diagnoses could occur multiple times for an individual. If you're going to use the incidence proportion for factors which could occur multiple times, then you need to also decide, are you going to count the first event or what are you going to count as the transition? Now, an incidence also needs to be tied up with some kind of time. There is time needs to elapse, and you need to report what that time is. You can't just say the risk of something. It has to be the 5-year risk or the 1-year risk or something like that. And the reason is, well, the risk of death, for instance, is 100% for everyone. Everybody's going to die at some point, and so you need to say the risk of death over a 5-year period was such and such. The incidence proportion ranges from 0 to 1, or 0% to 100%. Okay, so this is the risk. Okay, it's the percentage of individuals who transition over a certain period of time. We can also calculate the incidence odds, which would then be the magnitude of the proportion. So it's the proportion, or the risk, divided by 1 minus the risk. And again, odds are not always super intuitive, but it's the number by which we should multiply the incidence proportion of non-transitioners to the incidence proportion of transitioners. So if the incidence proportion, or the risk, was 80%, then it's 0.8 divided by 0.2 equals 4. The odds are 4 to 1, so for each non-transition, there will be 4 transitions. So here, just as before, 4 individuals who don't have the factor. After 5 years, 1 individual has transitioned. The odds are now 0.34. So the odds of transitioning are 0.34. And after 10 years, the odds was 3. Just like with prevalence odds, incidence odds have convenient statistical properties. Sometimes we have no option. They range from 0 to infinity. And when possible, we'd like to represent incidence as risk rather than odds, if possible. With incidence, there is a fourth measure which we should look at. At first, it might feel a little intimidating or a little bit hard to understand, but actually it allows us to look at something very important, and that is reoccurring events. So I said before, when we look at the incidence proportion, you'd have to make some decision. Are you going to look at the first event? Because every individual can only transition once. Otherwise, you end up having more than 100% risk, which is a little bit weird in that sense. But the incidence rate, we can solve that with. So if we just read what it says here. So how many transitions from absence to presence in a population over the amount of person time accumulated in that population? Okay. So if one person is followed for 1 month, then they've contributed 1 person month of time. If 5 persons are followed for 1 year, then they contribute 5 person years over time. If 1 person is followed for 10 years, then they contribute 10 person years of time, and so on. So we're just basically adding up the amount of time elapsed while we're studying the number of individuals. Right? If 100 persons died among 1,000 persons followed for 5 years, then we have 100 events. There are 1,000 persons, and they were followed for 5 years. So they accumulated 5,000 years, person years. Right? That's how many years in total we studied these individuals. And the incidence rate was 100 over 5,000 equals 2%. So you had 2 events per 100 person years. And I think that is easier to understand. So you need to understand all of this to really get to this, but this sort of puts it into context. So it makes sense. So you're counting the number of events that occur, the number of transitions, per, for instance, 100 person years. Or you could also do per 1 person year or per 10 person months. It depends on how long and what kind of scale you're measuring at. Okay. So if we look at this, for instance, we start at time 0 at baseline. Our 4 individuals, none of them have had the event yet. So none of them have the factor. After 1 year, there's one person that has transitioned. We've collected 4 person years now. We've had 4 people in our cohort, and it's been 1 year. So now we've collected 4 person years. We've observed these individuals for 4 person years. We've had 1 event, which is 1 quarter then. So it's 25%. So the incidence rate is 25%. And we can say for every 100 person years, we'll see 25 events. Okay, year 2, this person transitions back to not being a case. Then year 3, this person is a case. Year 4, not a case. Year 5, not a case. So this individual now has had the event twice. They've transitioned twice. In year 2, there were 2 other individuals that transitioned, and so on. So let's say that we did a calculation for year 4. At year 4, we have 16 person years because we followed these 4 individuals for 4 years. So now we've collected 16 years worth of observations. And we've had 6 events. That was 1, 2, 3, 4, 5, 6. The incidence rate is 37.5%, so we could say for every 100 person years, we'll see 37.5 events. So you see, it's quite convenient in the sense that we're actually removing the dimension of time, calendar time in the sense. We're just saying for how many total years did we observe individuals. And I picked years here, but it could be days or weeks or months if you want to. And now individuals are allowed to go to transition back and forth. So for instance, if we were looking at how many units of alcohol an individual drinks, then we would have to use a rate because you could drink more than once over a week, right? So you wouldn't only go from being not having consumed any alcohol to having consumed alcohol. You could actually have 3 or 4 glasses, and we would like to count every single event, right? And then we would have to use a rate. We couldn't use risk, for instance. So it can measure reoccurring events, which is very helpful sometimes. As I said, person time is its own timeline. It's separated from calendar time. It can be scaled to months, years, whatever sort of suits the study. Now, it does assume, and it's a strong assumption, that 1 unit of person time is exchangeable with another, and that's rarely the case. So what do I mean by that? Well, imagine, the time that we collected this, 1 year of observing this individual here, between baseline and 1 year, is exchangeable with 1 year over here. So I'm not making a difference between this observation and this observation, even though they are 4 years in between. I'm saying that all of these years that I observed are exchangeable with each other. And that's probably not the case. As we grow older, our risk for certain diseases increase, and therefore years later on, let's say we did this study for 20 years, the years that we measure year 19 are probably very different with respect to the risks involved compared to the first year. And so the assumption of exchangeability might not always hold, and that's something to consider. It might be useful to report how long it took to collect the data, as I did here, but in reality that's not strictly necessary because we removed calendar time. We're just talking about person years. In this case, for instance, we had 16 person years. That was collected over 4 years. But if I had had 16 individuals in my study and I'd studied them for 1 year, then that would also have been 16 person years, right? So calendar time is sort of taken out of the equation, but it might still be useful and informative to report the amount of time it took to collect the data. It ranges from 0 to infinity, so since we can now change the time scale, but also recurring events. And it has some really useful properties, as we shall see very soon.